So this is the main idea of today. Just for introduction, antivirus look for sequences of bytes in the programs, in the binaries, in memory that are suspicious, that probably mean that this code is malware. Probably. And it's not 100% sure, but probably these sequences of bytes mean something bad. For instance, this sequence uh, is the binary representation of the string /bin/sh. Okay, this is probably a sequence inside a shellcode that expands a shell. Okay? So if if an antivirus looks for this sequence and finds it somewhere, probably this means that probably this means that this code is trying to launch a shellcode, a shell, and maybe um, okay. So the first idea we are going to implement, I provide you the answer, is to encrypt this script, this sequence of bytes. I'm going to encrypt the string /bin/sh. Okay? And here, note that this string is 1, 2, 3, 4, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8 bytes. So this string fits in a 64-bit register. Okay? We are lucky, and here I'm moving to the register EX the binary representation of the string /bin/sh end of string. Okay, I'm very lucky because it fits exactly in a 64-bit register. Okay, but this is the encrypted version. This string here is the encrypted version of the string. And these two sentences here, these two short instructions here, are decrypting using the short function. First, I decrypt the first half of the string, and the second instruction decrypts the second half of the string. Okay, so after executing this short instruction and this short instruction, now I have the correct string. Okay. So these four instructions move this funny constant and register AX. Then I save this data into the stack. Next, I decode the first half. Then I decrypt the second half. So after the execution of the second short instructions in the stack, now I have the decrypted version of the string. So in the stack, I have /bin/sh rule byte, and then I can call the exec the system call. Okay, so here in this code, I'm encrypting the suspicious string /bin/sh using a very easy encrypting mechanism based on the short function. Okay, the short function, all of you know what it's. The truth table of the short function is very common. So I apply this truth table to every bit of the string. Okay, this is a first approach. It's not very sophisticated. We are going to do that to do in a better way. And I'm going to encrypt all the shell code, not only a specific part of the shell code, but all the shell code, using the same encryption mechanism, using the short function. Okay, the short function has this very interesting property. If I apply a key to a short, uh, yes, a key to a binary, to a value, and then I apply again the same key, the result is the original value. Okay, that's the one to encrypt and to decrypt. Okay, to encrypt, I apply the key once, and to decrypt, I apply twice the key. Okay, so this funny property, this interesting property, allows me to use exactly the same function to encrypt and to decrypt. Short function encrypts the shellcode, and later the short function will decrypt it. But obviously I need to use exactly the same key, otherwise it doesn't work. If I use the same key, if I use the same key, the result is the original one. Okay, so I will apply to all the bytes of my shellcode a key, one byte, random byte, one specific selected byte to every one of the bytes of my shellcode. Okay. Obviously, you can think on more sophisticated encrypting functions and decrypting functions, but it's out of the scope of today. Okay, we just use this simple function. So, the roadmap. First, we need a shell code to encrypt. Just in slide 7, this is the starting point we suggest you. Okay, usually we have to obtain the binary representation. Okay, this shell code is modifying. So if we place it in the stack, we need to make the stack executable. Okay, we need to make the stack executable using this flag. We have already done these kind of things, so we are familiar. If we place a string, if we place the shell code in the text section, we need to make it readable, because by default the text section is not readable. Okay, depending on where you put the shell code, you need to use some funny parameters. So, we are going to encrypt the shell code. One problem, shell codes must not contain null bytes. So after applying after encrypting the shell code, we don't want null bytes in the encrypted shell codes. Okay, we don't know. We don't want null bytes in the original shell code, and we don't want null bytes in the encrypted shellcode. So we have to look for a short key that does not generate null bytes. Okay, so there are only 256 possible short keys. So just using a forced root approach, you can find a valid one. Okay. Okay, and we need a function to decrypt the shell code. Okay, so this function we provide you. This function if you analyze the code, is very simple. It's just a loop that decrypts sequentially all the bytes of the shell code of the encrypted shell code. Where is located the encrypted shell code? Here. And from here, we will put all the encrypted shell code, okay? And the resulting shell code will start executing this small loop that decrypts all the bytes placed from here until the end of the code section. Okay. So, so here in this link, you can download a C program that we provide you that it's quite easy to understand. Reads the shell code, the original shell code, finds for a valid short key and selects one valid shell finds looks for a short key that does not generate null bytes. Okay, so we read the original shell code, we find a valid short key, we create a shell code with a decrypt function. The decrypt function is this function here, and appends after the decrypt function appends the encrypted shell code. And finally, the program dumps the code. Okay? So we provide you this code. You can download, you can try, you can test it, you can analyze. So the result of executing this program on the original shell code is a new shell code that starts with the decrypt function, and, and after that, the program puts the encrypted original shell code. Now, with this shell code, you have to insert the shell code in a typical placeholder, and if you execute it, if you compile it and you execute it, a new shell is created. Okay, so test it, it should work. We provide you all the code needed to reach this point. Okay, and if you want to place this slide is just if you want to place your shell code in the text section. Okay, if you need to modify the protections of the memory pages, that you don't need them. You don't need really you don't really need this information if you put the code in the stack. Okay, so well, okay. What are you supposed to do in this second lab? You are supposed to improve the short encoder. In which way? The encryption we provide you is using a single byte short key. We are applying to all the bytes of the shell code exactly the same short key. But we are going to use a multi-byte short key. Okay, instead of encrypting all the bytes with the same short key, we are using a 2-byte short key, a 3-byte short key, and up to 8-byte short key, and, uh, and just in a round robin way. Okay, so this is the work we are supposed to, well, we are asking you to do. And for simplicity, you can put knobs in the shell code just to make the length of the shell code multiple of the short key length. Okay, so if you need, just add 2, 3, 4 no operations at the end of the shell of the original shell code to make it to make it easier to apply the multi-byte short key to all the bytes of the shell code. Okay, so this is your work in this lab, and this lab accounts for the 30% of the total mark of lab 3. By the way, I publish the marks of lab 2 and lab 2 of lab 1 and lab 2 in Atenea. You can check. No, no lab exam. Okay. Next week you have free time. You can. So you have another. You have 2 weeks for
Igual te pone,
for
viste,
completing the obfuscation.
bueno, si lo hizo como el 1, como
The last week of
los
obfuscation.
resultados, pero no la nota.
Obfuscation. Okay.
Te da el resultado.
And that's all.
Sí, no. Eso hasta el final, supongo.
So you can
Cero,
start working
no.
on this exercise, or you can try to finish the previous one.
Sí.